Continuing my discussion about converting different values into binary and those binary values into, for example, decimal or hexadecimal, I'm going to show you the hexadecimal conversion here. These are the digits of a hexadecimal number. You see that we have 16 different digits starting from 0, then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. So you can see that we start with 0 and end with 15. So the 15 is, presented by F, 14 is presented by E, 13 is presented by D, 12 is presented by C, 11 is presented by B, and 10 is presented by A. So we have 16 different values. Now for converting the to binary, we do not need a whole bunch of bits. Actually, we need as much bits to accommodate 16 values inside that. So if we go for 4 bits, you know that each bit can have 2 different values, 0 or 1. And if we incorporate 4 bits, we can have 16 different values. So we are going to use only 4 bits. We are not going for 8 bits or more than 4, whatever. So I want to assign values to these 4 bits here. The first placeholder, the second placeholder, the third placeholder, and fourth placeholder. The first bit, if it is 1, it is going to have a value of 1. The second bit, if it is 1, it is going to have a value of 2. The third bit has a value of 4, and the fourth bit has a value of 8. So you see that this is the same as what we have in normal, when I gave some values to the bits. I wrote the placeholder in previous session to show you the different binary values for different bits in an octet. Here we are going to have only 4 bits. Okay, now I want to start by values. If I want to present 0, what I need to do is to give all of these placeholders a value of 0. So 0, 0, 0, 0 is going to be 0. For 1, it is easy. 0, 0, 0, 1. That's because all of these are going to be 0. They are not receiving any value, but this one, the bit is 1, so it is going to receive this value, so it equals to 1. So let me show the other values. If I want to have 2, it is going to be 0, 0, 1, 0, and you know why. For 3, I have 0, 0, 1, 1. 4 equals 0, 1, 0, 0, and so forth. So you can assign different bits, different values, and you can have these equivalents in hexadecimal or even decimal. Now I know that I need 4 bits to represent 1 digit for hexadecimal. So where do we need to know hexadecimal notation? Actually, when we are talking about IPv6, we are going to use hexadecimal notation. IPv6, we know that IPv4 is 32 bits. Okay? We show these for 32 bits in 4 portions, and each portion has 8 bits. So each portion is an octet. So this is going to be 4 octets. Here in IPv6, we are going to have 128 bits. So this is a whole bunch of bits. We cannot go for 8 bits portion. We are going to have 16 bits portion. So we are going to have 8 portions, each 16 bits. So each portion again is called an octet, and I'm not sure why it is called an octet, because it's 16 bits, but whatever, we call it an octet again. So we have 8 portions. Each portion has 16 bit, and you know that 16 bit can be shown in 4 4 bits. And we know that each 4 bit can be represented by a hexadecimal value. So we can have 4 hexadecimal digits inside a portion. So again, this is why we go for hexadecimal notation, because we can have a 16-bit portion divided into 4 different 4 bits, and each 4 bit can be represented by a hexadecimal digit. So you should know about this. So if I have, for example, 1 0 0 1 1 1 0 0 0 1 0 1 0 0 0 1, this is going to be an octet that has 16 bits, and I want to divide this into different 4 bits portion. This is the second one, this is the third one, and this is the fourth one. Now I convert these into hexadecimal values. You know that the fourth bit has a value of 8, this has a value of 4, this has a value of 2, and this has a value of 1. And we know that only this and this are going to receive their values, because this 2, 1 do not have any values. So we know that 8 plus 1 equals to 9, and 9 in hexadecimal is represented by 9. Okay, the next one. We have for this 8, for this 4, we do not have anything here, because 2 and 1, they are not going to receive any value. So we have an 8 and we have a 4. Is equals to 12. And you know that 12 in hexadecimal is C. Let's go for the next one. Here we have an 8, we have a 4, we have a 2, and we have a 1. And we know that 2 and 8 are not going to receive any value because they are 0. So we have a 4 and we have a 1. It is 5. And 5 is represented by 5 in hexadecimal. This one is very easy because this is 8, does not have anything. This is 4, does not have anything. This is 2, does not have anything. But this is 1 and it has a value. So the value is going to be 1. So we know that 1001, 1100, 0101, 0001 is going to be 9C51 in hexadecimal. And if I want to show this in hexadecimal, I want to make sure that what I have done is correct. So let's open the calculator, and I want to go for binary notation first. Let me drag this up a little bit so that I can see this easily. We have 1001, 1100, 0101, 0001. And if I try the hexadecimal value, it is 9C51, exactly as what we have calculated here. Okay, let me give you another example. Here I want to give you another 16-bit, and this time I'm going to write this wider so that I can see that better. Okay, I have an octet. I have a portion of an IPv6 IP address. It has 16 bits, and the bits are like this: 1001, 1111, 0000, 0101. So I need you to convert this into hexadecimal. So you will go for this one. I mean this procedure. This is a 4-bit. This is another 4-bit. This is another 4-bit, and this is another 4-bit. And you know each one of them should be treated differently. So I know the values. This is 1, this is 2, this is 4, and this is 8. And let me write this. This is the value that each one of these bits receive. And again, this one is going to be 8, 4, 2, 1. And 8, 4, 2, 1. And again, 8, 4, 2, 1. So I need to sum all of those bits that have a value. You see that this one doesn't have a value. This one doesn't have a value. But this one and this one has. So this is going to be 8 and this is going to be 1. So the result is 9. The other one, all of the bits are on. So all of them are going to receive the value. So this is 1 plus 2 plus 4 plus 8. This makes this 15. And we know that in hexadecimal, to show the 15, we use F. So let's go for the next one. All of the bits are off, so they are not going to receive any value, and the sum of all of them are going to be 0. So this is the easiest one to calculate. So let's go for the last one. The last one, this doesn't receive anything, this receives, but this doesn't receive anything. So we have a 4 and we have a 1, so the result is going to be 5. So let's calculate this using the calculator and make sure that we are correct. So let's go for binary. Here I type 1001, 1111, 0000, 0101. And if I hit hexadecimal notation, I can see this is 9F05, exactly as what I have calculated. So you see that this is very easy to convert hexadecimal into binary. Now I want to do the opposite. What if I am given a hexadecimal value and they ask me the binary value for that? For example, I have 2003, and this is one of the octets in an IPv6 address. I'm not going to go for the rest. They ask me to convert this into binary. I know that each one of these will have 4 bits inside that when converted to binary. So the first one, 2. If I convert this into binary, this is going to be 0, 0, 1, 0. And I'm not going to tell you why. You know that. This is going to be a 1, this is going to be a 2, this is going to be a 4, and this is going to be an 8. You see that only 2 has a value, so the result is going to be 2. So you know this. Let me do the rest of my calculation. 0 is very easy, 0, 0, 0, 0. The next 0 is very easy too. It is going to be 0, 0, 0, 0. And the last one is 3. So that's going to be 0, 0, 1, 1. Okay, let me go for calculator again. Here I want to type a hexadecimal value 2003, and now I want to hit binary notation. You can see that except the first value and the last 2 bits, all of the bits are going to be 0, exactly as what I have calculated. Let me give you another example. This is going to be a little hard. So they gave me this value. They say 2AFC and convert this into binary. So I know that, let me select another color, that's better. I know that 2 is 0, 0, 1, 0. Okay, A is gonna be 10. If I do not know anything about A, I just remember that A is 10. I can of course start counting to reach to A and make sure that A is gonna be 10. So I have 8 in 10. So the remaining is gonna be 2. In 2 I do not have a 4, so I add a 0 here. I have a 2, so this is going to be 1. And I have nothing remains, so this is going to be 0. Let me write this. The values are going to be 1, 2, 4, 8. And I told you how to convert decimal into binary. The same procedure can be repeated here to receive the hexadecimal value and binary value, of course. So we see that 10 has an 8, so this is going to be 1. It doesn't have a 4, it has a 2, but it doesn't have a 1. So this is the result, 1010 for 8. Okay, F is very easy. I know that F is 15, so all of the bits are going to be 1, 1, 1, 1. And the last one, C. I know that C is 12. If I do not know, I will start counting. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. A is going to be 10. B is going to be 11. And C is going to be 12. And for 12, I need to know the placeholders. I have an 8. The remaining is going to be 4. I have a 4, but I don't have a 2 and don't have a 1. Again, let me write the values so that you can calculate that easier. This is 1, this is 2, this is 4, and this is 8. We know that we have an 8, the remaining is 4, we have a 4, They remain in 0, so we do not have a 2 and a 1. So the result is 8 and 4 receive their bits set to 1, but the other places, no, they are not going to receive any value. So this is the conversion from 2AFC into binary. So let me drag this up and again go for calculator. In hexadecimal, I type 2, and here is A, here is F, and here is C, and I hit binary, and the result is that 2 precedent zeros that do not show up in calculator. Then we have a 1, 0, 1, 0, 1, 1, 1, 1, 1, 1, 0, 0. This is exactly the same as what I have calculated here. So now you are comfortable with converting binary into decimal and decimal into binary, and again hexadecimal into binary and binary into hexadecimal. The last thing I want to talk about is converting hexadecimal into decimal, and that's going to be an easy part.